Hey everybody, it's Mr. Carr again. Today we're going to be talking about 7A Day 1, talking about exponents. Okay, so in all of Unit 7, we're going to be covering what's called polynomials, and that's what our first vocab term is. Okay, so let's look at some more of these. So what is a polynomial? A polynomial is going to be an algebra expression made of many terms. Okay. It gets its name because poly means many, and that's what we're referring to on that one. Okay. Let's jump around. We're going to go to terms now because that's part of that definition. Let's define that. So a term is any number or variable or multiplication of numbers and variables. I'll do numbers and variables. Okay, so a term would be something like this. 3x is a term. Okay, when I look at that, that means right there, that's a combination of 3 times x. That gives me a term there. Okay, so if I look up at a monomial, that is a single term. Okay, that's what's in the mono there, so that's just a one term idea. Okay, so a polynomial is made of many terms, and there's a variety of them. So for example, I could do 2x plus 5, or I can do 3x squared plus 4x minus 1. Okay, these are 2 terms. This is 3 terms. We separate terms by addition and subtraction. A single term is going to be like my other one down there where it's like 3x. That's a single term. Okay, even if I did something like this, if I have the number 5, that's also a single term, and that leads me to the next term, constant. Okay, these are just numbers. Okay, numbers that are not multiplied by any variables. Okay, so if I ever describe something as a constant, I'm referring to just a number with no variables at all. Okay, quotient, that is an answer to a division problem. Okay, so that should be a review of something in the past before. Also can be written as fractions. Okay, this is the other part you might see it. So remember that quotients can be represented as a fraction because technically I'm doing dividing with a fraction. All right, so we come down here, determine whether each expression is a monomial. Remember, this is going to be a single term. Okay, write yes or no, and then explain why. All right, give me just 1 second on this one. Okay, now we're back. Let's take a look at these. So remember, to be a monomial, okay, there is no addition or subtraction. Okay, so that's what we're looking at here. So for example, A, this is not a monomial. Okay, we have 2 terms. That would be my reasoning why. So it's no, there are 2 terms. Okay, part B, everything is multiplied together. 8 f squared g. This is yes, it's a single term. Okay, everything is combined in through multiplication. Okay, so that'll be my explanation. We're gonna pause it there for a second. Or not. Okay. That's fun. All right, everything is multiplied. 3 over 4? Yes. It's a constant. Okay, and a constant is a term. Okay, without any variables, it still counts as that. For D here, I'm saying here specifically multiplication in those 2 spots, but really everything's multiplied together. So I'm going to rearrange this. I'm going to do 2 times 3 times 10 times x times y, which is going to be 6 times 10 is 60xy. So this is also a yes. Okay, same reason as B. Everything is being multiplied together. Okay, our first property we're going to talk about today is what's called the product of powers. Okay, so what happens is this: to multiply 2 powers that have the same base, we're going to add their exponents. This is a shortcut. Okay, so this is how it looks right here. If I say a to the m power, a to the p power, if I'm multiplying with a is the same base, okay, so in this case it's a, the base is a in both the cases there, their exponents m and p get added together like this. And here's a couple of examples of that. If I take b to the third power times b to the fifth power, that's the same as b to the 3 plus 5, or b to the eighth, okay? I like to use this as a quick example. Think about if I do something like this. If I am taking x squared times x to the third power, okay, what exponents represent is repeated multiplication. So this means that's an x times an x. This one here is x times x times x. Well, this is all being multiplied together. If it's all x's multiplied together, I can put them together with the same base of x and just count up 1, 2, 3, 4, 5 of those x's. So that's my exponent is x to the fifth. The shortcut is just taking the 2 and the 3, add them up. We don't have to separate them and then put it back together as 1 again. We can just count up the 2 plus 3 gives me 5. So for our example 2 here, as we go through here, again, it has to be the same base. So I look at this, I'm multiplying these together. Negative 12 does not have anything to multiply by. So I'm actually just going to bring negative 12 to the front. The r to the fourth and r to the seventh, those are being multiplied with the same base. So we can apply our property here. We can just add the 4 and the 7 together. So negative 12 r to the 11th power. Okay. Next one, negative 2 and 3 can be multiplied together. So I'm going to do that. That gives me negative 6. Then I'm going to have an x squared times y squared times x. The only ones that have the same base are the x squared and x to the first. So those can come together and make it negative 6, x to the third power, y to the second power. All right, and then part C, same ideas. 6 and 5 can come together. So multiply that to 30. Okay, then I've got c to the first times c to the fifth. Okay, and then d to the fifth and d squared. So these two can go together. So that's going to give me c to the sixth power. And then these two go together. So that's 5 plus 2 is 7. All right, d to the seventh power. So that's our first main idea besides all the terms. When I multiply with the same base, we can add our exponents together. That's what we're looking for here. The next one is the quotient of powers. Okay, and that's when we are dividing two powers of the same base. Then we're going to subtract the exponents. And again, let's use this as a quick example. Let's say I have x to the fifth divided by x to the second power. That's the same as 5x's on top, 2x's on bottom. In this fraction format, I can actually cancel out these common x's like this. Okay, so I can get rid of 2 of them from the top, 2 of them from the numerator, 2 from the denominator. I'm left with x to the third power. This property is a shortcut because instead of doing it as writing it out separately like this, I could just take 5 minus 2. 5 minus 2 gives me 3, so that's my shortcut. Okay, and so that's what's happening here. We are just going to subtract them as long as it's the same base. So you see that here. C to the 11th divided by C to the 8th. That's the same as C to the 11 minus 8, which is C to the third power. Okay, so for example 3, again, it has to be the same base, so I'm just going to compare the two a's. So we got a to the third over a to the first. So that's going to be a to the 3 minus 1. B is got 9 over 2. So I'm going to do 9 minus 2. So that's going to give me a squared, b to the 7th power. Okay, for the next example, 20 and 10, those are the ones that I can do a problem with. Some people think that you want to subtract these, but remember, we are only subtracting exponents. So 20 over 10, I could just do that as a fraction, which is 2 over 1. So that's what's going to happen. That's going to turn into 2 over 1. Okay, x to the 7 minus 6, y to the 12 minus 3. Okay, I don't need to write this over 1 anymore, so I'm just going to write the 2. 7 minus 6 will give me x to the first power. 12 minus 3 is y to the 9th power. Okay, the only thing being subtracted are exponents. All right, for part C, First thing is these are being multiplied together, so I can kind of show that multiplication is like this. Now it's kind of like my previous problem. I have a fraction that's 5/20. So I'm going to reduce that. Both of those are divisible by 5. So 5 divided by 5 is 1. 20 divided by 5 is 4. So my answer is going to have 1/4 in that answer. Then I have x to the 4th, and then minus 1 because I have that x to the first on the denominator there. So my final answer is 1/4 x to the 3rd power. Okay, that's it for these properties. We'll have more in the future lessons, but two main ones. If I multiply with the same base, we add our exponents together. If I divide with the same base, we subtract. Okay, all right, that's it for today. Take care, everybody.